my clock reads 11, so I'll kick things off here. Welcome to an Integrated Sustainability webinar on drought adaptation. I'll kick things off here with a bit of housekeeping. First, we'll do a land acknowledgement. In the spirit of respect, reciprocity, and truth, we honor and acknowledge this land, Mokisis, and the traditional Treaty 7 territory, along with the oral practices of the Blackfoot Confederacy, the Stoney Nakoda, and the Tsuut'ina Nations. We acknowledge this territory is also home to the Métis Nation of Alberta, Region 3. We also acknowledge that our Vancouver office is situated on the unceded territories of the Coast Salish people, consisting of the Musqueam, Squamish, and Tsleil-Waututh nations. Finally, we acknowledge all nations, Indigenous and non, who live, work, and play on these lands, and who honor and celebrate these territories. Thank you very much, everyone, for attending. The format of today's webinar is a quick presentation. I'll go over some of the basics, kind of frame the discussion with the panel. Just going to introduce, or not introduce, but just kind of just want to highlight the fact that we have three subject matter experts on that. So compose your questions for them. So we'll introduce them after the presentation. We have Adam Phillips, who's going to talk about expanding borrow pits and converting fresh to produced water. We've got Emily Guzman, who's going to talk about the environmental and regulatory pathways to make some of these alternatives possible. And we have Vance Matthews, a hydrogeologist, to talk about groundwater questions. And I'll field a few around water treatment. But this is really, we're trying to highlight here a couple of things. One is that some of these basin alternatives are really multidisciplinary challenges. So tackling them, requires some studies sometimes, requires, this blend of constructability and or technical know-how with regulatory and field work and those kinds of things. So that's really what we want to bring to the fore is these solutions are complex to a degree, but if you have the right multidisciplinary team, that complexity gets flattened. So the agenda today is a little bit of what I just mentioned here in terms of what are the advisories with what is the state of the affairs in terms of what the government's telegraphing. We've all seen kind of some updates from them saying likely basin shutdowns. What does that mean in terms of how they're quantifying the risk and when does what kick in terms of license shutdowns and suspensions of operability. We also want to talk about the alternatives, the 6 alternatives we're proposing that companies start to investigate if they haven't already. I mean, a lot of this is going to be checkbox for some of the folks in the audience, but some of them, hopefully, we bring a couple of ideas that that folks have said, yeah, that's not a bad idea. I haven't really thought about that. And then again, jot down your questions, put them in the Q&A section of the webinar, and we'll start addressing those with the panelists at the end. So I'll start with Alberta and then we'll move to BC afterwards. We're entering into some territory here that Alberta has not seen in terms of its gated management stages here. We are in stage 4, which is a space that if we've ever been there, it's certainly pretty rare. And what does this mean? Well, it really means that the status quo is getting suspended. TDLs, temporary diversion licenses, are already at risk. There is going to be a lot of initiatives kicked off, including information sharing and collaboration between agricultural basins, and various other government parties, wherein exactly how much water you've been using and scrutiny on and shutdowns of basins might be declared at any time. So really, what we're saying here is, we've already declared a stage 4 in Alberta, and it is not unlikely that we will hit a stage 5. And that's never been implemented before. And that is a bit of terra incognito. How stringently will regulations around stage 5 be implemented? Will there be extra leeway? Will water restrictions be eased a bit just because of the effect this will have on industry? Certainly first in time, first in right is still a guiding principle, but even that is not, going to be inviolable in terms of the collaborative nature to which to which a stage 5 will give the government and regulators tools to say, this is not a normal time. Please step outside of your box. So the drought conditions, you know, a lot of this information on this slide, we'll make this available afterwards. There's more detailed information for a lot of folks in different areas to look at. But really what we're saying here is there are tools here to quantify the risk to your business. And that'll be a theme I think I returned to several times. I don't think anybody in the room is unaware that there is a risk to their business. I think one of the challenges is saying, well, quantify that, because that's certainly probably what your executives want to see. If you're showing up saying, I want to invest money in some of these alternatives, some of the ones we're proposing, or some of the ones you've already got in hand, to spend money that's not already appropriated in a budget, requires some homework, requires some quantification. Well, what exactly is it? What is the likelihood? What is the percentage? And so I think a lot of the information available in certain platforms, and certainly from companies like Integrated Sustainability, we're certainly doing this for several customers already, is to quantify that. What is the percentage likelihood? And that's an opinion, but it's also backed up by a lot of flow data and trends and other information gathered over the years, but also you know, just historical analysis as well as present stream gauging data that's indicating what the likelihood is of water bodies like the Wapiti and Smoky and Little Smoky getting suspended. Moving on to BC, I mean, a lot of the customers and a lot of folks in the room are, you know, maybe headquartered in Calgary, but also operate in BC, obviously. BC is in even worse condition than Alberta. I mean, BC was really entering this stage 4 kind of space here last year. They already had some restrictions and so on, but certainly this year it looks especially dire. So, you know, they're already kind of blazed this trail. A lot of those customers have already begun to ask us to look for alternative sources and water conservation efforts and reuse and that kind of thing. So BC is really, unfortunately, staring at very likely suspensions. You know, there's even the big Peace Basin is straining, and when the Peace gets strained, then you know you have a broadband problem. You know, certainly basins that were closed last year will remain closed this year. There's certainly no indication of sufficient snowpack to change that. There is always the possibility of an excessive rain event, but one-off rain events don't really change the landscape that much. Certainly, there are customers who have enough in storage to weather 2024. But this is really in BC, especially a 2023, 24, probably even a 2025 situation. So this is one of the more long-term drought impacts to the oil and gas industry in BC that probably we haven't seen since the oil and gas industry really took off in BC. Again, we can share this kind of information with you, but you can see that you know, almost all the basins in Northeast BC are severe, or if not severe, getting very close to that. So we'll make this data, you know, this is, I guess, an example of the kind of data that you can use to help quantify the risk to business. So the EPA, otherwise known as, well, the Environment and Protected Areas, so that the renamed Alberta Environment and Parks, you know, they're like I kind of touched on this before, and again, you know, put your questions to Emily at the end here, but they're certainly requiring license holders to provide more information, prepare risk analysis, these kinds of things. What are your options for managing? And certainly, if you're making applications to say, you know, can I go above and beyond the acceptable flow limits, a lot of these kinds of data points are going to be asked. So a little bit of this is doing some upfront homework to prepare yourself for additional questions from the regulators. If you're going to ask for special permission to dip into stream flows that are above and beyond what's currently allowed. I think that, the same is true. We're talking a little bit about EPA and AER, but the same is true of BSER and the British Columbia regulators. They're going to want to have the data or regional, very regional specific flow monitoring. So I think your big weapon is to do more stream gauging, as an example, to get very fine-grained regional data as to what the water streams are doing. You don't really want to depend entirely on the aggregated stream gauge at the further downstream. So there are some aspects to buttress probably the information you already have, update it maybe, and really start to cross-reference that with your drilling, with your demands during drilling and completions. So this is the part that folks are probably most interested in. What exactly has integrated sustainability got up their sleeve? I mean, a lot of these you will already know and probably doing, but certainly one of the ones we would like to bring to the table especially is non-saline groundwater. Not a lot of this is done, with the possible exception of Cardium groundwater in Alberta. There is some experience there, and that's probably a bit of our precedent per se for saying that this is very doable. You don't go for non-saline or even saline groundwater when you have abundant surface freshwater. It's more expensive, obviously. There's all kinds of interesting operational aspects to this that require things like maybe above ground HDPE to convey it, and so you can't use lay flats and so on and so forth. It's a category above or a category aside from freshwater. This is really where we're saying we need to start to step outside of our comfort zone with freshwater. It's just not going to be available in certain areas. And so what's plan B? And I think part of this using non-fresh groundwater in this equation going forward is to say that these kinds of drought conditions are going to occur several times over the course of your asset life. So we're building infrastructure to last 20, 25 years, 30 years in some cases, including reservoirs and intakes and so on. You're also, if you're digging a freshwater pond, you're probably going to trickle charge it with some fresh groundwater. Well, we're saying that going forward, non-fresh groundwater sources should be added to that, especially in the case where you are already pumping and reusing produced water, but also in the case where you're not. And there's some options there in terms of how to move it or how to make it fresh enough to move in lay flats that we'll discuss in a bit here. I think one of the biggest things about the non-fresh groundwater discussion is that it has much less regulatory scrutiny, of course. Now you have to prove it's not fresh groundwater and so on. But by and large, there's no Water Act. Well, there is no Water Act license required to withdraw it. There are some regulatory things to do, and Vance can speak to those in the panel discussion. But it is a reservoir. It is an ocean of water per se under our feet that can be used, especially if you've made you've crossed the line into deciding to begin to reuse produced water. I mean, I stole a bit of thunder from here already, but Northeast BC has been reusing its produced water for some time because of disposal constraints. Alberta has in fits and starts, certain operators have. Certainly some areas in Alberta are becoming disposal constrained, and so those operators in those areas are really starting to look at produced water recycling. I think one of the big blockers to produced water reuse has been, ironically, in most cases, a low amount of flow. So a lot of operators have said, we're kind of interested in doing this, but it's a lot of capital to deploy for what's coming out of our gas plant, for instance. So maybe 1,000 cubes a day or 1,500 cubes a day. We really have to save up for a long time to make one frac possible. But if we add the previous slide, a non-fresh groundwater to the equation, then we can, with the same infrastructure spend to reduce your produced water, double or treble or quadruple the amount of water in that system. Now, there's all kinds of questions, of course, that have to be resolved around the chemistry and blending those two, and how much would that groundwater need to be treated to be mixed into that system. But those are all easily identifiable or quantifiable aspects that can be that can be determined with stuff like OLI chemical modeling. Industrial and municipal effluents in the province of Alberta. I mean, we have customers who've already gone down this path, and there are operators speaking to, for instance, the city of Red Deer or towns like Beaver Lodge, and have agreements in when they can pull water. There are other operators we've chatted to who are in the process of figuring this out. How do I take the water out of these lagoons that the municipality has said go ahead? I think one of the challenges with this is its scale, its proximity to where it's how do you transport it? It is a group 2 water, at least that's what they call it in Alberta. It's a bit fuzzier in BC in terms of what a water that's going to be discharged to the environment is actually classified from a different industrial. One of the areas that we've championed in the past and certainly worth looking at now in this context is pulp and paper mills, and they certainly have a large outflow of relatively good wastewater that could be harnessed. We had a project called White Fox Pipeline. You know, these are the kinds of things that can help future-proof your business, especially over the long term. This is a possible 2024 in terms of lay flatting this stuff around. Again, it's basically a proximity question. There are some things in here like bacterial loads that probably need to be addressed. So the chemistry issue is certainly there. You wouldn't want to put the wrong bacteria downhole and cause your well to go sour. So there's some things like that to cross T's and dot I's. Again, it's a lot like produced water, and blending these all together is certainly something that needs a little bit of attention to detail. I think mostly the challenge here is establishing commercial agreements. We've gone down the path and made it available, but the uncertainty about where or how much completions is going to need or take over time causes producers to balk at saying, I will commit to X amount to make this feasible. So with this drought, really a wake-up call to what is my plan B if the basins get shut down. Those kinds of agreements, I think, are going to become easier. And there's certainly going to be, certain producers are going to be eager or a little more maybe willing to pay a bit each year and use this fluid to have that plan B, which would be scalable and get first right of refusal on additional water there. So those are some considerations, and we certainly have a bunch of relationships, for instance, at pulp and paper mills in Western Canada. I spoke a bit about this earlier. The real question here is how close is it? How deep is it? How much does it cost? And how do you transport it? And I think the takeaway is if you do not have produced water recycling in your playbook right now, this could almost be a bit of a dry run, if you will. Pardon the pun, because it's not a dry run. But what I mean by that is, if you have good saline groundwater fairly proximal to, say, 2 or 3 wells, how would you get it to those wells? How drilling it is obviously straightforward. I don't think there's anyone in the room who doesn't understand that. But getting it to the wells is a question mark. How much would the well produce? If you really needed it to depend on it, would you need multiples, and how would you bring those together and get them there? If you needed to treat that to, say, knock out iron, or if by chance it's sour, would you need a tank to dose it with something to get the sour down, and so on and so forth. So there's a few bits of questions there, but it's very doable, and the regulations allow. That's one of the questions that says, is this allowed? And the answer is the regulations do allow it. And certainly, for stuff like cardium, which is a group 2 and effluent, it's already being done. The saline side is not, to my knowledge, being done right now, especially for oil and gas producers, but it's a near step out from what's already being done, and the regulations do allow for it. So really what we're talking about for 2024 is probably above ground HDPE line, and extra C-rings at the well pad is probably the quickest and fastest way to add thousands of cubes per day to your water supply. Beyond that, it can certainly be blended with produced water, like I mentioned before. So, or if you have existing freshwater infrastructure, there's a real option to turn that into produced water infrastructure, and I speak to that in a couple of slides here. More on saline groundwater a little bit here. the mapping of it and the figuring out how much of it is available is really, I guess, part of the equation. Vance will speak a bit to this a bit more here shortly as to what's publicly known, what is already in hand. Also, you as producers who have drilled a lot of holes in your asset might have information to this as well that can be applied to that situation. You might task your geos with going to go look for this stuff, and then it's simply a groundwater well exercise, i.e., flow pump tests and so on and so forth. So it's probably, the acumen is probably well within your company already to do a lot of this. There's a little bit of regulatory to figure out. There's pipeline routing, all of these surface pipeline routing, all of these are not rocket science and done in a lot of other aspects, and we have a lot of tools already in hand to make that happen quickly. Yeah, these as a layman, these don't mean a lot to me, but again, Vance can answer all these questions at the end. Fifth in this equation here is, there's a lot of reluctance by some producers to move saline groundwater and or non-saline, non-fresh groundwater around just for the corporate risk it presents. And so depending on how much TDS is in that water, certainly at the 10 or 20,000 TDS, probably easily all the way up to 30,000 TDS, there's off-the-shelf membrane technology that can handle this. This is effectively like desalination of seawater. And if it's at 10,000, it's a much less onerous equation than even seawater. Seawater is at about 30, 35, depending. But so membrane technology for that kind of water and desalinating it is relatively straightforward and easy. Once you move up past that into 50 or 75 or 100,000 TDS or above, the membranes really start to get challenged, and the pressures are incredible, and the OPEX climbs. There are some new membrane technologies that purport to be able to handle it. They're probably not commercially available, or at least not for 2024. And in that case, there are some thermal technologies. And so we've helped one example of that get to market. There are others that are being brought to the fore as well. So you can essentially distill produced water or saline groundwater and turn it into a freshwater, effectively a freshwater, to make lay flat transportation, traditional lay flat transportation, a possibility. So those are some other ideas to blend in there if you want to make use of existing fresh infrastructure and not convert it to produced or saline groundwater infrastructure. This is an option for doing that. There are some rules and regs that are tricky. If you distill produced water to a fresh standard in Alberta, you still can't mix it with surface fresh water until you're at the C ring at the well pad. In BC, you can blend those in your produced water. You can take a freshwater pond in Alberta, drain it of its surface freshwater, and put that distillate in there. So there's a few nuances there from each of the provinces in terms of how to manage, the output of these kinds of technologies. Certainly, the availability of it. Some of these have long lead times in terms of getting solutions in hand. Some of them are rentals that are available immediately. But understanding the cost benefits as well. Does it make more sense to pipe that fluid directly as an above ground HDPE, or does it make sense because of the infrastructure you already have in hand to desalinate it? And lastly, we've chatted on this a bit already here, but converting existing infrastructure is doable. We've done it on numerous occasions now. You take the existing reservoir you have and you apply the rigor that is required for produced water ponds. It's not to say that potentially you didn't place this freshwater pond somewhere with a lot of receptors that make it ill-suited for produced water storage. But by and large, it's all mitigatable with, it's all engineering per se, right? It's mitigatable with extra liners and extra protection and extra sumps. And so the several times we've done it already, that it has been very straightforward with the regulator, who sees same due diligence to managing it as we do in our regular produced water pond efforts. I think the other thing to add to this equation here that I will throw in there that Adam can speak to is expanding borrow pits. So if and when we do get a rain event, those one-off rain events or two-off rain events that come and dump a lot of water, how quickly could you expand existing freshwater. Well, certainly the ponds you've already built are probably, you're not going to really dive into those. But borrow pits can be expanded and without too much pain incurred. Certainly, 100,000 cubic meter reservoir is a pretty commoditized item. Excluding where slopes are steep or where there's other challenges with terrain. They're pretty commoditized. They're fairly well understood, and something under 3% slope and in a decent soil condition is you're bidding those at and around that $1 million mark. So potentially adding more of these in 2024 if and when one of those rain events occurs, and you can capture some more water from a swollen river and or surface water. Capturing that surface water is certainly something that should be examined. I think the last piece, and I don't know that a lot of the folks on the call, certainly the folks in Northeast BC, collaborate a lot. I've been told anecdotally, by the way, that a lot of the collaboration in terms of, well, I got some water, do you want it, has gone away as people are starting to hoard water in anticipation of this. But certainly collaboration never hurts, and I think there's going to be some collaboration forced on some producers that have never done it before in terms of, well, you're not using most of this license. What exactly is your anticipated? Because we want to release some of it to others. So there's very much this idea of if, for instance, there's an alternative source out there that we really need two of us to make it viable. Those are the kinds of conversations to begin to maybe have, and we, Integrated Connect is an idea board for what are some possible collaborations between producers that maybe wouldn't have done that in the past, but in today's environment would be more willing to do that. I'm going to speak briefly to the implementation of some of these. By and large, like I mentioned earlier, it's the analysis of risk that really generates, moves it beyond anecdotal into more concrete logic and justification for increasing spends, or at the very least, the spend required to get Plan B ready. And so that's one of the big ideas I want to throw down here is, this idea of, well, these are fine, but they're expensive. If I really need it, I might do it. But they're ouchies, and so I really don't want to do them unless I have to, and that's understandable. A lot of these are tough. These are not easy answers compared to surface freshwater. But taking the information you already have and filling maybe a few gaps in terms of exactly how much you're going to need based on your frac schedule, and then really looking at each of your sources and saying what is the percentage chance that and how much storage can I pull out during even a low freshet, and can I move frac schedules around to spread that risk out, but critically, can I quantify this to say to my execs to say, look, here's some real data that is saying this won't be available to us, so let's move forward on the beginnings of a Plan B to assume it won't. Now, if it does become available, great, we don't execute on Plan B. But if it doesn't, let's get 100 meters ahead of the start line here and be able to execute those in a relatively short timeline, so that we're not looking at a 2025 and potentially a real impact to completion schedules in 2024. These are some great graphs that I'm afraid I can't really explain to you. These will have to be advanced chat. They'll probably ask me to back up some of these slides later on. But regardless, the risk mitigation strategies themselves, among the ones we chatted about, and probably some others that you've thought about. If you have a need for extra C-rings, for instance, these can be done fairly quickly, as you well know, but putting a 6-week delay because of an acquisition or a bit of regulatory, and especially if the AER has a whole flood of these come in at the last minute because of drought conditions, getting ahead of these might be a really good idea, so that you already have that in hand, and it's less a question of waiting for regulatory permits. You've done your whatever environmental look-sees need to happen. You've maybe felled some trees. You've got a bigger laydown yard that could accommodate 2 extra or 3 or 4 extra sea rings if and when, for instance, those non-potable groundwater sources become a real game changer for you in 2024. And so get ahead of it, I guess, is with the smalls studies, the groundwater studies, and so on that make those Plan Bs for 2024 much more accessible from a timeline perspective. I've got some timelines here. We'll share this afterwards, but in terms of what these typically look like, there's a lot of 2 weeks and maybe a 1 month and so on and so forth, but they add up. And so, by the time you add all these up, you're looking at 8 weeks or 10 weeks, and some of the longer ones, i.e., for instance, a Cardium groundwater application. Some of these take longer, and so if they're going to be part of your playbook, or at least the deck of cards you have in hand to be able to play, to put those in your deck, begin the relatively inexpensive, compared to executing on the relatively inexpensive regulatory applications and studies and so forth to support those regulatory applications. I'll throw this in as a last slide. A lot of this, these different sources of water and where you're using them and how you're managing them, they do represent a data headache as well. We have field telemetry tools to throw at challenges like, well, how much am I moving where, and how much do I have when, and how much have I pulled out of this well and this well and this well, and so on. We, as part of being an attendee at this webinar, if you're interested in using GeoCata as a tool, we've got a bunch of customers who do use it to track their water and so on. It makes a great tool for regulatory applications as well. So this is part of that supporting toolkit that makes the regulator feel really good about how you're managing this, and supplementary information requests are dealt with quickly and timely as well. So with that, I will wrap up my presentations. When we say know your risk, I think what I would change that word to right now is quantify your risk. And so this is really, we've seen excellent examples at some companies where the executives are fully aware that it's not well, we think it's going to be bad and we're in trouble. They have quantifiable numbers, of course, that have probabilities associated with them, but that the executives can really mull over and say, this is the impact to our bottom line in terms of ducts instead of completed wells. This is what it means for opportunity costs to not have completed X number of wells from that schedule. This is what it means to our stock price if we have to go back and say we couldn't complete on our plan because we didn't have water. And that really, at least gives your execs the eyes open decisions around it. And to say, what, doing this and this and this make a ton of sense compared to the opportunity costs of X number of uncompleted wells because we couldn't get the water, or postponing those wells, and so on. So I think the real takeaway is get that risk very quantified. Start your Plan Bs, the relatively inexpensive studies and regulatory applications to get Plan Bs ready for deployment if need be. But also think about 2025 in terms of the planning, because if 2024 is in hand with reservoirs you already have, it's going to be a challenge to fill them for 2025. And so know what a drought in 2024 also means for 2025, and maybe begin the planning for that as well. So with that, I will introduce our panelists and the questions that have come in from the attendees. Vance Matthews is our technical director of hydrogeology. He comes to us from a variety of locations, but most recently Suncor. So he's here to answer the questions about the saline groundwater aspect, and non-saline, saline, but also groundwater. I mean, certainly there's a lot of folks who are going to jump all over every groundwater source they can. So how do you most efficaciously find those sources, determine their volume, figure out what's the most amenable to your operations, and how to convey those waters to their source. Emily Guzman is our senior regulatory lead. So she's here to answer the questions about, well, what does the regulator say to moving these things around? And what does that landscape look like for some of these solutions? Adam Phillips is our senior program coordinator for civil earthworks. So he's here to answer questions about, for instance, converting fresh ponds. What does that effort look like, and what does that timeline look like for achieving that? How viable is that? Or expanding borrow pits is certainly one of the ones he's bent my ears a few times on as something that we should really be encouraging our producers to do if and when there is these abundances of water in this drought that may come for a little more than a week because of a rainfall event. How do we make best use of those with the expanded storage? So with that, I will start answering or proposing questions from the field, and I need to figure out where I'm getting those from, actually.
Yeah, Yves, I can help you with that one here.
Oh, brilliant. Thanks, Adam.
Yeah, we've got a few questions in from the crowd already. So maybe we'll start on a bit of the regulatory component here. It's obviously probably heavy on a lot of folks' minds, but we'll direct this over to Emily here. But noting the management stages kind of identified earlier of the drought conditions, do you feel like the regulators will completely cut off the available diversions? Do you feel like there's some leniency around those diversions outside of any of the environmental flow needs or instrument objectives? Kind of maybe what's your take on, as we get into this uncharted territories, about operational leniency where possible?
Thanks, Adam. Yeah, from what we've seen and what we've heard from the regulators, I think they've been doing a great job of communicating with industry as we are rolling into this period. As we can see, things are not lightening up and potentially getting worse in certain situations. And they've been doing their part on their end to communicate this with us regularly. We know that they've been taking steps on their end to review and assess hydrological conditions, especially in these areas where there's river basins that are highly allocated, and we know that there are multiple operators working within. They have highly developed and mature assets. So these are definitely moved up on their priority list. In terms of how they've been communicating outside of just the bulletins and news advisories, I know that they've also been reaching out to license holders just to understand what their current water demands look like for the projected 2024 year, so that they can compare this against the forecasted availability. So there has been a lot of work on their end in terms of reviewing this. And from what I can see is that in certain cases, based on these results and what they've been doing, there has been some leniency in terms of allowing diversions where we might see lower flow levels, seeing how that water can be allocated between different operators. So I definitely think this is a case-by-case basis. By no means I think we're suddenly going to see an opening in all rivers, but yes, I think they are working with us diligently to see where they can help and where these issues can be alleviated.
Great, thanks, Emily. We've got a bit of a follow-up sort of related to that, and kind of going back to maybe what you said, spoken about earlier about sharing water resources. So in absence of sort of new sources, maybe coming back to that shared water resource perspective, can you touch on what the current take is from the regulators, and so maybe some opportunities there, and maybe any hindrances that you see in that water sharing of resources?
Yeah, I think this is something that has been ongoing. It's not new or new concept brought because of these current drought conditions. This is something that we've seen even on a normal operations of sharing of water infrastructure, especially where we have an existing infrastructure set up. There's pathways that are already existing to allow for multiple operators to use the same infrastructure, minimize their disturbance, minimize the regulatory pathways for this. So we have seen this, and this is going to be continuing as much as I can assume that as we move into this, and hopefully, it gives operators the confidence that this is an already existing pathway for them. Of course, with sharing infrastructure, there's things on the operator's end that they'll need to do in order to make sure that they have the appropriate approvals and pathways existing between themselves. So basically understanding your schedules, water needs, and that way there's no unintended overlap. If this means also sharing resources with other sectors, for example, municipal effluent, there is also an existing pathway for this. We know that both on the operator side and then also the municipal provider side, there's a bit of a regulatory process that is involved on both ends in terms of permitting this for that use, but it exists and it's definitely encouraged if there is allocation available. Of course, again, there's always license conditions on both ends, but that's definitely by no means a showstopper.
Emily, just to add to that, I mean, one of the questions I have is we have a well-known customer who has just a gusher of a groundwater well and doesn't use nearly all of that groundwater water. Sorry, that ground well water. What are the options for someone to come along and use part of that groundwater that was licensed for a different producer? And I guess same, you know, if somebody's got 500,000 cubes under storage and they're not planning on using it, I don't know what condition, I don't know what space that would be in, but if you know, they had an asset that has a full pond and they're going to be drilling somewhere else, but they pulled that water from a surface source on their own license, is there a pathway for a different producer to come along and use that water?
So depending on, I guess, the conditions of the license, like you said, if someone's, you know, we've seen it in cases where someone's identified that they have an over allocation, meaning they don't necessarily need that full supply of water. Potentially this is a temporary thing, or it could be, you know, for the foreseeable future. There are pathways to do a license transfer allocation. So a portion, not all of your license, can be transferred to somebody else for those needs specifically. There's also processes that we can discuss in terms of acquiring like a rediversion, you could almost call it, of that license. So just ensuring that that water is not, we're not double dipping, just to say. So going through that regulatory back process in terms of ensuring that water can be moved, and then it's not, like again, a saying that double dipping, we're not diverting additional water, it's just repurposing or removing.
Great, thanks, Emily. Maybe I'll pivot a bit here. We've got a couple more questions. Coming to the groundwater conversation here. Vance, this is probably directed to you here, both from a licensing perspective and a technical perspective. You know, maybe give us some concept on, you know, what do you think the lead time is on the regulatory side? What are the requirements sort of within that realm to garner access to that deep saline water and or fresh water? What are some differences that you've seen between the two?
Yeah, so there are just a few differences with respect to non-saline water, which is considered water that has total dissolved solids 4,000 milligrams per liter or less. One of the things that I've found is the non-saline water, which is a little bit more accessible, easy to get at, maybe a little less costly to pursue from a drilling perspective, is there have been instances in my experience where the groundwater source has been potentially connected to surface water, and so it's been directly under the influence of surface water, and that is an issue that's pretty difficult to license. The issue around that is that the concern is that the groundwater supply sources are vulnerable to contamination from surface water or precipitation. In terms of saline water is typically a lot deeper, a little bit more expensive to go after. You can have some compatibility issues related to that. Maybe some surface water management with respect to the volumes of water that you want to manage at the surface and transport, and potentially compatibility. There is a good chance, though, with the deeper saline sources, because you don't need a Water Act license for saline water, which is water that has above 4,000 milligrams per liter TDS. You don't need that Water Act license, and if you're lucky, you can find a nice thick, deep aquifer with a very high pressure head, good permeability, where you'll be able to source a large volume of water from that well.
Vince, those don't require any kind of mineral rights or anything like that, do they? I mean, it's a space nobody wants, and so it's more or less take what you want, or how does that work?
Well, so the PNG mineral rights gives the operator access to the fluid in the pore space in the reservoir, whether it's petroleum, natural gas, or saline water. You still have to go through the same approval process or licensing process for a well. You just don't need a Water Act license.
Excellent. Got a question here more on the sort of on the civil and the storage side. I mean, it kind of leverages off of what Vance is speaking to in the groundwater access. Now, what do we do with it? You know, Adam, there's lots of borrow pits certainly out in the landscape. Maybe walk us through some of those initial steps in converting borrow pits to freshwater ponds, or freshwater ponds into produced water ponds. You know, as that storage medium, as that backup to take advantage of fresh it and use it at a later point.
You bet. Thanks, Adam. Yeah, so as Eve mentioned, we've done this before. Sites change hands and change uses. So to get them to change uses, the first thing we typically do is ask for all the existing site data we can have, survey what the actual planned use is, what the planned use was, just so we have a good holistic view of the site. From there, we can look at previously completed geotechnical data, but generally we're going to have to go out and complete a bit more of a program, especially if we are going to convert to produced. We want to know what's deeper below the pond, make sure there's that vertical separation between the base of the pond and any domestic use aquifer. So we'll go out, we'll punch a few geotechnical holes. If we can plan it perfectly, we will also complete those holes to complete the hydrogeological assessment to go along with that. So we'd like to button everything up in one nice little visit, analyze that data, use that data to support the issued for approval drawing package for the civil, and all the dam safety documentation to support that. Work closely with Emily through that as well during the regulatory application process. And yeah, once that all gets carted across the line and approved, then we move into the detailed design phase to design the facility to meet the producer's requirements, and then from there, tendering and construction.
How much civil is required? If there was somebody out there with 100,000 cube pond, I mean, are we talking a lot of civil construction, or is it very minor? I mean, I know there's some sump construction, but other than that, is it fundamentally different materials, or is it a matter of adding sumps and liners?
You know, I guess again, to that end, it's site specific and depends how long it's been sitting saturated or dried out. We want to, above all else, you can't have a good liner system unless you have a really good subgrade. So, you know, we'll have to get into an assessment on that site, determine what the thickness of the poorer soils would be. We can either remove that, farm it out, dry it, recompact it, and build a solid subgrade, or just take it out completely, which will ultimately change the size, the volume of the pond. Beyond that, too, we need to put in a subdrain if we have liners to prevent hydrostatic uplift if there is groundwater present. And then we also like to deepen that sump so we can have 2 to 3 different layers to monitor leakage from the liners and or the subdrain below. So realistically, end of the day, there's not a significant volume of earthworks. It's more of just an art of like planning each piece bit by bit to make sure things flow smoothly.
That borrow pit conversation, I mean, if somebody has a 30,000 cube borrow pit, which I hear quite frequently, I mean, expanding that, is that feasible to expand one of those to 100,000 relatively quickly, or is it more in the space of 50, 60? You can kind of double it, but
the biggest factor to that depends on the regional topography. If we have a huge drop off then beside us, then, you know, we're going to have a bigger embankment. If we have like a nice flat area, well, yes, we can keep on going. We want to avoid those big embankments, and that's a lot of dollars to move that dirt to build those berms.
Excellent. Thanks, Adam.
Yeah.
Emily, there's a lot of regulatory questions in here for you, so we'll kind of layer these in. Coming back to some of the restrictions that we're expecting. You have a water reservoir, you have an existing sort of diverted storage. Do we foresee there there being an ability for the regulator to restrict or limit access to that water that's already been diverted out. So an existing pond, for example, that has water been diverted, is there a possibility of restricting access to that? What's your take on that one, given it's sort of out of the environment element?
Yeah, I guess, yeah, that's an interesting question. To my knowledge, and from experience, I have not seen this previously. Typically, assuming that you have an existing water license that is in good standing and was diverted during the appropriate timing and flow conditions, meaning that there was sufficient flow, you've done your monitoring, you can demonstrate that that was done in compliance, and that water was then moved to your approved storage location under your license conditions. That water would then be removed, I guess you could say, from the aquatic system, and that would be in your storage component to then later be used. Just understanding the way that the licensing works is basically once that volume has been removed, it is then considered a consumptive use. So unless there is a specific condition, and we see this a lot on our municipal or sometimes maybe in commercial licenses where they're treating the water and then putting it back for return flow, there might be some sort of those sorts of conditions. But typically for a lot of our operators, this is considered a consumptive loss. So then that would then be able to use in your operations later on. I haven't seen any indication that storage, water in storage will be restricted. Really, I think the regulators are pushing to get your storage filled or as closest to maximum capacity so that you can then have this mitigative option when low flows later down the road for drought.
And maybe a follow-up on that, sort of on the flip side of that, with noting that there's drought conditions coming. Do you foresee the relaxing of some things, some regulations? For instance, a lot of conversation about above ground lines for produced water. Do you see the ability to push that mandate a little bit more to enable the transfer of fluids amongst the basin, or obviously in the case of produced waters, move that water more easily amongst one's assets?
Yeah, so this typically, produced water being moved in above ground, that was not a conversation previously. A couple years ago, that wasn't an option that was available to us. However, the AER has released the Directive 77, which allows for the transportation of produced water, which is that Group 3 water, and also Group 2 water, which is your municipal effluent. This is now an existing pathway, one that we've worked with our operators in terms of going through the notification and approval request process. So yes, there are new avenues and new pathways that have opened up to allow for these sorts of things. We definitely can work with you in terms of planning. These are great options, especially like we said, if you have a developing asset and just need an option for short-term transportation. This is something that we can definitely work with you on as you start developing or maturing your asset and putting in that permanent infrastructure.
Excellent. We will pivot a bit here back to the groundwater conversation. We do see a lot of wells sort of on the landscape, whether it be shallow or intermediate depths with maybe limited production or limited productivity. Vance, can you maybe speak to some of the steps in improving those wells, the re-entering old wells to improve production? What are some steps that you kind of take from a hydrogeologic perspective to improve those efficiencies or improve the production of those wells?
Well, I guess it really depends on what's going on with the well. How much has been produced. If you're seeing boundaries in the aquifer, what the well maintenance schedule looks like. If there's any downhole fouling, there's a whole number of different issues that could potentially happen. I've even seen issues around productivity related to pumps malfunctioning. and variable frequency drives. So there's a whole bunch of things that need to be looked at in order to, I guess, optimize well use. And so that's probably what I'd first start to look at in order to determine if there's anything else. It would be a sort of a stepwise process.
One question I have for you, Vance, the fresh groundwater. I mean, as a layman, my perception is if in this drought condition I go looking for fresh groundwater, is fresh groundwater going to get affected markedly in the next year or two, or is that a much longer process in terms of the water table dropping and fresh supplies getting impacted? And B, is this going to be a case of, well, maybe it's an Emily question, I don't know, but the use of the regulatory use of or approval for fresh water during a drought is also going to be as constricted as removal from surface. Do we foresee that new fresh groundwater sources are going to be very restricted?
I would expect so for non-saline water. And when you go through the process of evaluating the pumping test data and writing a report and preparing it, you have to develop, what your sustainable yield over a 20-year period will be for that water well. And certainly in that process, you have to take a look at what potential impacts to the environment there are and present that to the board in order to get a Water Act license issued. And I would say that that's a pretty important and sensitive topic, certainly in a drought situation. I think there'd be a lot of scrutiny around that for sure. Because the way I'm thinking about it, with a drought in place, I would expect groundwater tables to fall if those aquifers are providing base load or base flow to a river or a stream. If that base flow drops and the inflow streams or volumes reduce, I would think that would be a significant issue. So you wouldn't want to. I wouldn't think that the board would want to license a water well that would impact surface water like that.
Excellent. And I guess one more question I had, anyway, was, and I'm ignorant, so I apologize if this is a dumb question or not. But if I had old wells that are pretty tapped out, but they made quite a bit of produced water, but they're no longer viable from a perspective of oil and gas production, but they're producing. Is that a pathway to turn on old wells and turn them into saline groundwater wells? Is that doable, or is that a ridiculous idea?
You could take a look at something like that. I guess I would kind of wonder what the water quality of that water is, and if that's going to be a potential issue. And then, of course, what the pressure head is, the perm, and the available, I guess, well yield. You'd want to take a look at that to see if it's worthwhile trying to bring something like that online.
Emily, maybe a follow-up on that from the regulatory side is what are your thoughts on that sort of conversion of use from the regulatory perspective?
Yeah, I guess the first thing that comes to my mind is that well was obviously licensed for a different purpose, so we might have to go through the process of amending the well license for the new purpose. So changing that, providing the applicable information so that we can classify it as a source well, of course, for saline groundwater. So given that the TDS is greater than 4,000 milligrams per liter, a Water Act license would not be required. It would just be in terms of amending the well license.
Great. Adam,
Actually,
unless you got
one
more
more
question
actually
to squeak in here,
yeah.
Sure.
Yeah, one more if we got a couple of minutes. I'll put it out to the panel here. We've kind of seen the BC side of the world utilizing freshwater, produced water, and recycled water used a little bit more, maybe so than in the Alberta case. I'll just throw it out to the panel here about just some thoughts on some reasons why that might be, and maybe how to push that along a little bit further within the Alberta context. So again, just open it up to everybody here.
Yeah, I mean, I can speak to that broadly speaking, not technically, of course, but broadly, the BC disposal situation is not as clear cut as the Alberta one. So Alberta has been blessed in most areas with abundant disposal, and so that's been the cheapest, quickest way to deal with your produced fluids. In the British Columbia side of the border, and especially in the Montney it's less clear. There are spots and there are, difficult deep spots to do disposal. And so they've had a driver, an economic driver to do it, especially the producers that have a higher volume of produced water. It was going to be an enormous expense, the number of disposal wells and how often they would have to bring new ones on board. So it made a lot of sense to spend the money on produced water recycling. So that driver has really been absent from Alberta by and large. That's starting to change in some areas for sure, but by and large, the disposal's been more than adequate for what Alberta's generated. I think what's causing Alberta to move in that direction is some of the ideas we've already talked about. ESG has changed the landscape considerably. There's a lot more pressure on freshwater. Disposal's available, but it still costs a significant amount of money, and so there's less of a status quo. Just dispose of it. I've talked with several producers who are saying, well, I can get most of the way there for the cost of my new disposal well over here, or that one over there, or tying it in. All this, all in, drilling it, surface facility, tying it in. It's cheaper, but it's not a lot cheaper. It's not $1 to a $20 bill by any stretch of the imagination. So, I think the drivers in BC really pushed the conversation, and it is beginning to come to Alberta more and more, especially when people are saying we're going to be seeing droughts for every 5 or 6 years. Like this is a real potential. Every time an El Nino cycle comes along, we might be in the same boat. And so I think there's a lot of folks that I've never chatted with about produced water before are starting to look at it. And, they're really taking into consideration the big elephant in the room, which is, we like to do it, but we can't move it around easily. And so new gathering systems as they go in are by and large getting an extra water pipe put in the ditch. And that's really facilitating that produced water recycling. And so as that starts to become more of a standard playbook in Alberta, the optionality to do produced water recycling and the cost associated with it are really going to drop. We're at 2:02, so apologies, panel. I used all of that up, but closing comments. I know there's probably some more questions out there, and some of them are similar in nature to the ones we've answered, but different enough to warrant a follow-up. So we're certainly going to produce an FAQ, as is our way. Additionally, always we're here to answer the questions that come to you in half an hour or this evening. While you're listening to a podcast or something, you have another question pop up. We're happy to have more conversations with you individually and specifically around your areas and what a groundwater investigation would look like, or what a conversion would look like, or what a regulatory path would look like. So we can bring any of these panelists and any other experts we need to bring to the table to become your trusted advisors on some of these topics. So let's keep the conversation going. If and when you have more questions, we'd love to be part of those. Thank you very much for everyone for coming. And again, these don't matter unless you come to attend, and your feedback is pretty critical. So you might see a feedback request coming your way. Please be honest and forthright. We want to know that we're providing value. These take up a lot of resources on our end, and the more value we can generate for you, the more worthwhile they are to do. So with that, I'll wrap things up. Thanks everybody on the panel and Adam for stick handling questions, and we'll wrap up our webinar there.